Okay, thank you. Good morning and a very warm welcome to all of you joining today's virtual session, which has the honor of being the first pre-event and side session of the Asia Water Forum 2022. My name is Wendy Walker and I'm the Chief of the Social Development Thematic Group at ADB, and I'm providing the opening remarks for the session and then we'll hand over. It's going to be a really exciting week with a wide range of speakers, topics, and opportunities for engagement. I'm delighted to be opening this session on pathways for quality-oriented growth through a resilient and water-secure Asia and the Pacific. And speaking on behalf of ADB, we were really pleased with the outcomes of the 4th Asia-Pacific Summit and the recognition that strengthening action on water sustainability is key to promoting a sustainable, resilient, and inclusive post-pandemic recovery. The COVID-19 pandemic has been devastating to the region. ADB has estimated that the pandemic has pushed an estimated 75 to 80 million people in developing Asia into extreme poverty in 2020, compared to what would have happened without COVID. It has also exacerbated existing inequalities and barriers for vulnerable groups, such as the poor, informal sector residents and workers, and particularly women and youth. The pandemic also highlighted the critical importance of access to water and sanitation services in building resilience and the critical role that technology can play in helping to anticipate and assess impacts and ensure inclusion. These last few years have underlined again how important achieving a resilient and water-secure Asia and Pacific will be to meeting the SDGs. Allow me to mention the collaborative work that my group in social development has been doing with ADB's water sector group to accelerate our efforts and develop a technical note that will incorporate poverty reduction and social dimensions in water supply and sanitation systems projects. Water is essential for social welfare, poverty reduction, and livelihoods, and the development of this technical note will outline the sector-specific issues for conducting robust poverty and social analysis that can improve the well-being of communities through water supply and sanitation system projects. We hope that this joint work will help water sector professionals and decision makers improve their focus on sustainability, inclusion, and resilience in project design. So as we discuss this week how to improve water security in Asia and the Pacific, and today's session on how to improve how improved water security can support quality-oriented growth, it's important that we also consider specific strategies to ensure that poor, women, and vulnerable groups are considered in water sector security planning, whether through improved governance, by increasing women or ethnic minorities' representation in decision-making bodies, such as water user groups, or through technology and such as GIS or specific social protection measures, such as targeted pro-poor tariffs. So thank you, and I look forward to hearing from our exciting lineup of speakers and panelists for this session, and wish you all a stimulating and action-provoking conference. Thank you. Over to you, Mark.
Thanks, Wendy. Thanks, Wendy. Can I extend my welcome to all of you who have joined this session and will join the event this week. My name is Mark Pascoe. I'm Chair of the Governing Council of Asia Pacific Water Forum. I recently took on that role and participated in the Kumamoto Asia Pacific Water Summit. A quick introduction. Asia Pacific Water Forum is a network of institutions across our region who are fundamentally interested in water security. And indeed, the 4th Asia Pacific Water Summit brought us together, somewhat delayed because of the pandemic, but brought us together in a significant event held in Japan and supported by the Japanese government. My colleague Yumiko Asayama will present some of the outcomes of the forum, but today is really meant for us to explore a little further the challenges that we have in securing our region for water going into the future. Asia Pacific Water Forum has worked, indeed includes in our network the Asian Development Bank, and we're very pleased to be able to run this session here this morning. I think you don't need to hear too much more from me. I will moderate the session, but can I please hand over to Yumiko Asayama, who's the executive for the Asia Pacific Water Forum based in Japan.
So thank you so much for Wendy and Mark for wonderful opening remarks for this side event. My name is Yumiko Asayama, Chief Manager of Japan Water Forum, and also the Secretariat of the Asia Pacific Water Water Forum Secretariat. Actually, I would like to briefly into the outcome of the Host Asia Pacific Water Summit, that is Kumamoto Declaration Chair Summary, and Kumamoto Initiative for Water, which is announced by Japanese government. The Asia Pacific Water Forum, which is Japan Water Forum, is taking the secretariat role, successfully organized the fourth Asia Pacific Water Summit in last April in Kumamoto and online to share the forward-looking solution and practice with heads of states and the government and support their decision to accelerate the action to realize quality growth toward a resilient and inclusive and sustainable society. By organizing the fourth Asia Pacific Water Summit in hybrid format, we provide the government leader to express their country's practice to each government leader and confirm and gain confidence that government leaders' the strong leadership is essential to solving water issue. Thanks to the Japanese government achievement, we were able to achieve the successful Asia Pacific Water Summit in terms of the highest level participation. For instance, we kindly organized a summit with the participation of Their Majesties and the Emperor and Empress of Japan, and His Majesty and the Emperor kindly gave commemorative lecture. In addition, 18 heads of states and governments and 20 ministers of Asia Pacific and Europe kindly joined the deliver their statement for the fourth Asia Pacific Water Summit. That includes Japan's Prime Minister Fumio Kishida participation in Kumamoto and deliver opening remarks and keynote speech. In addition, 20 heads of international organizations, including the United Nations Secretary General Antonio Guterres and ADB's Vice President, also delivered their statement for the Asia Pacific Water Summit. In terms of the thematic achievement, we have three main deliverables. One is Kumamoto Declaration, the second is Kumamoto Initiative for Water by Japanese government, and third is fourth Asia Pacific Chair Summary. Firstly, I would like to introduce the Kumamoto Declaration. Kumamoto Declaration is a joint statement and declaration to address water challenge and transformation toward a quality-oriented society by 18 heads of state and government in Asia Pacific. We are able to adopt this declaration anonymously thanks to the support from the focal point of these government organizations. The head of states and the government reaffirms the water is critically important.
Nakita mo yung note ko.
It is also emphasized government leader also identifies the necessity to reduce disaster risk, achieve multiple SDG, and strengthen transboundary cooperation by resolving the sound water cycle. So Asia heads of states and government identify the importance and the necessity to transform toward a quality-oriented society to realize inclusive, sustainable, and resilience for their quality-oriented growth, and the necessity to do that in terms of science and by enhancing the measure in terms of science and technology, governance, and finance that is supported by quality infrastructure, including soft and hard components. In order to accelerate the effort, government leaders also confirm the necessity to improve governance, closing the financing gap, and appeal to the science and technology community to enhance the context-specific innovation, respecting natural environment, geographic feature, and historical background of each local community of Asia-Pacific, promoting education and capacity for governments, not only for government organizations, but also for new generation for their water professional. Second achievement is the Kumamoto Initiative for Water. It is announced by Japanese government. Centering on the climate change adaptation and mitigation and measure and the promotion of measures to improve water people's basic environment, Japanese government kindly announced the Kumamoto Initiative for Water to enhance the quality growth in Asia of the Pacific through the support of Japanese advanced technology. Prime Minister Kishida also announced that Japan would provide financial assistance worth nearly $4 billion over the next 5 years to the Asia-Pacific region. The third achievement is the shared summary. This shared summary reflects the pathway toward quality-oriented growth. The shared summary is also the part of Kumamoto Declaration. The shared summary responds to the question from the heads of states and governments about how to address the barrier and breakthrough for improvement of governance, finance, and science and technology, compiling the key message of the 9 parallel thematic sessions and 4 integration sessions of the 4th Asia-Pacific Summit. The science and technology provides key critical role in resilient society, so chair summary emphasizes 3 necessary actions. The first is to promote water cycle resilience by accelerating open science policy, particularly focus on the observation, modeling, and data integration. The second is to foster the facilitator who can lead the way by providing professional advice on site using a broad range of science and local knowledge. The third is a collaboration beyond discipline and sector among different levels while adapting end-to-end approach gained in science policy multi-stakeholders interface. This is my last slide. In the 4th Asia-Pacific Water Summit, 18 heads of states and government identify quality-oriented growth as a growth that satisfies all 3 factors: sustainability, resilience, and inclusiveness. Asia-Pacific region is so diverse, so it is still necessary to transform the theory and concept into the actual implementation and action to enhance government leaders' continuous commitment and leadership by sharing the best available science and knowledge, experience, and lesson, collecting and making the case suitable for a variety of local conditions of the Asia-Pacific. Hence, we are organizing this side event to discuss how water sector can contribute to quality-oriented growth toward resilient, inclusive, and water-secure Asia and Pacific. The presenter and panelists of this side event will share their expert scientific knowledge and way to nurture human resource in Asia Pacific who can seek out locally tailored approach. Thank you so much for giving me the opportunity to introduce Host Asia Pacific Water Summit's outcome. Thank you.
Thanks, Yumiko. Thanks, Yumiko. Can we now move to the first presentation from Dr. Taikanoki. He is a professor at the Graduate School of Engineering at the University of Tokyo in Japan. And he's also advisor to the president of the Japan Water Forum. Dr. Oki, I wonder if you can provide your presentation, please.
Sure. Thank you, Mark. Do you hear me?
I can hear you.
Yes, great.
Yes, others can as well.
Okay, let me share the screen and briefly introduce something about that, how science, technology, innovation, and collaboration for water secure Asia. And of course, that my major is not everything about science, but I'm a hydrologist. So let me tell you that in general, how can hydrology as a science help achieving water security? Firstly, hydrology contributes for society by providing reliable data set of past and current global and local hydrological cycles and near real-time seasonal prediction of weather or climate and future hydrological cycles and the climate change. I will show you an example later. And also that hydrology contributes for society by giving answers to identify effective measures to be taken in order to secure the water supply, mitigate potential flood risks, to improve water quality, and to protect or to restore aquatic ecosystems. And also that science and technology and hydrology can quantitative answer about the quantitative estimates, how much water is and will be really available for water withdrawals and consumption for human beings. And of course, for the prediction, we need not only that future prediction of the natural hydrological cycles, but the social aspect, that how the population will be, how these population will be distributed, and so how much technology will be available, how much investment will be available. These factors should be also predicted, or that we need a scenario to give an answer to these questions. And let me introduce about that the latest research that the accepted manuscript is already online, but the formatted one PDF file will be online within a few days. So it's a hot outcome. So that this is the changes in the climatic risk boundary. So you see that the left figures, so that within the thick line, that we were in this climatic risk boundary during the 20th century. That horizontal axis is that once in 20 years, so that comparatively rare maximum temperature, and vertical axis is that maximum daily precipitation once in 20 years. So that this was that we were, most of the human beings, that the population density more than 1 or equal to 1 or more per square kilometers were living in this climatic risk boundary. However, it seems that if we go for that more than 4 Celsius degree of the global warming, that RCT 8.5, that we will be within this climatic risk boundary, so that these people will be exposed to the unprecedented climatic risk during the 20th century. But at the end of this century, they will be exposed. So this is an example of the East Asia, that during 20th century, we were in East Asian cities, or the regions were within this climatic risk boundary, or that the maximum temperature once in 20 years and once in 20 years of their daily annual maximum daily precipitation. and Sapporo or that the Khabarovsk, that even at the end of this century, that they were within that regional climatic risk boundary, so that we can learn in Sapporo people, they can learn from that experience within East Asia. But Seoul, Hanoi, and Hong Kong, Beijing, Xi'an, and Ulaanbaatar, they will transgress this climatic risk boundary of 20th century. So they need to learn from somewhere in other regions how to adapt to that the new climate risk for them. And Tokyo is on the border of that global climatic risk boundary, so that the temperature and precipitation that at the end of this century of Tokyo may be unprecedented during the 20th century. So that is the situation, and this is that the distribution of that the people who will transgress that past climatic risk boundary. So if we go for that, the more than 4 Celsius degree of global warming, that near more than 1/3 of the world population will be exposed to the unprecedented climate risk. And if we can limit that global warming less than 2 Celsius degree, maybe only 16%, but still there's many. And these colors indicate that the temperature only transgress that past experience, and precipitation only bluish colors, and both precipitation temperature that the people will be exposed to that unprecedented climatic risk, so that the reddish regions are unfortunately predicted to be under that the unprecedented climatic risk at the end of this century. And as you see, that not only that future climatic prediction, but we need to think about the population or societal development. And now that new discipline called socio-hydrology is evolving, and it can mean various studies, but the key is the interaction between the hydrological sciences and social science, or that water cycle and human society, these interactions. And in my case, not only that the climatic study of that global perspective, we have been collaborating with the Asian, Thai academia and officers. And this is some illustration on our project, which was called Advancing Co-Design of Integrated Strategies with Adaptation to Climate Change in Thailand. The project has just finished. 5 years project has just finished, but we have studied an urban area, coastal areas, and the sediment disaster, and freshwater and forest and rural areas. And all of these sectors, we collaborated with the local communities or local people to have monitor the changes and had a workshop how to adapt to that the progressing that the climatic change. And also that based on these regional case studies, we have developed a web application to show that each municipality, very fundamental local municipalities, more than 7,000 in Thailand. So what could be their major risk under the climate change, and what are the options they can take as an adaptation? So this kind of the sharing that the experience in the regional case studies should be developed and shared amongst ourselves. So the remarks, so we cannot solve any issue we cannot sense. So that observation is very important. I think that the following this session, we will have a talk about that, how the observation is important, either from space or the in situ. And water is the focal point of sustainable development, and water is a pilot. It integrates and leads our world for the better future. And as you see that the climate risk boundary issue, that smooth exchanges of knowledge and technology through global partnerships based on multilateralism is critically relevant for implementing applicable and efficient adaptation measures to climate change. So that I'm quite sure that this kind of side event or workshop symposiums are very important to promote such an multilateralism and share the experiences. Thank you very much for your attention.
Thanks, Dr. Aki. That was a good presentation and gave us, I think, a good example of how we need to integrate science and technology, and indeed integrate it with social issues. I'd like to move on now to a series of 3 presentations, which are going to sort of address once again how scientific knowledge can inform our decision making. The first presentation is Dr. Sanjay Srivastava. He's the Chief of Disaster Risk Reduction, ICT, and Disaster Risk Reduction Division of UNESCAP, United Nations Economic and Social Commission for Asia and the Pacific. Dr. Srivastava, can you do your presentation now, please?
Yeah. Thank you, colleagues. Hope you can see my presentation on screen.
We can see it. Can you put it in presentation mode, please?
Yes. Can you see this presentation clearly?
Yes.
Yeah. Thank you.
It's not in presentation mode, Sanjay. Next one, two more over. Yep, that's right.
How, is it okay? Is this fine now?
It's
Hello?
It's still not in presenter mode, but let's.
Then may I request our colleagues from your side to show this if it is fine? Or let me try again. Sorry for this. Is this okay now?
Hi, Mr. Sanjay. Can I share your presentation?
Yeah, I think that will be fantastic.
Yes,
Please
thank you.
do help me. Right, thank you. Thank you very much.
Can you unshare your screen, please?
Right. Yes, thank you, colleagues. First of all, I would like to sincerely thank Asia Pacific Water Forum Secretariat for giving this opportunity to UNESCAP for this presentation on pathways. If I come to my next slide, the next slide is going to tell you three key trends. You just heard Kumamoto Declaration, sustainability, resilience, and the inclusiveness, all embedded into Sustainable Development Goals. And if you look at the progress of Sustainable Development Goals of Asia Pacific, it's a recent report of UNESCAP 2021. The progress has been not only insufficient, but also slowed down in Asia Pacific regions. What is alarming is it has regressed on climate action, mitigation and adaptation on both the fronts, and sustainable consumption and production. So goal 13 and goal 12, both are directly related to growth, resilience, and water security. But when you come to resilience, that is reflected in terms of Sendai progress, this is yet another alarming trend. None of the Sendai frameworks, particularly those related to sustainability reduced targets, are on track to be achieved by 2030. Direct economic loss and damage to critical infrastructure, especially water infrastructure, have increased substantially over the past decades. So this is yet another challenge, particularly on sustainability fronts. But what could be the code red for human driven global heating IPCC report 2021 is climate change is widespread, rapid, intensifying, and some trends are irreversible. So intensification of floods, drought, tropical cyclone, heat waves. These are the three key trends. And in midst of these emerging trends, the issue of growth, quality of growth, sustainability, and water security is something a challenge for many of the scientific community worldwide. So the pathways lies in accelerating the implementation of 2030 Agenda for Sustainable Development and capitalizing on science, technology, and innovation as Kumamoto Declaration rightly captured. So my next slide is going to share with you one important, I should say, a very something truly challenging in the sense is the shrinking RLC in Central Asia. This is also reflects the transboundary cooperation state of affairs in today's context. You see, in 2000, the RLC in the past used to be sea on the land in midst of the arid, semi-arid region of Central Asia. You see the status in 2000. In 2004, you see the deterioration of the RLC quite clearly, evidently. 2008 deteriorated further. Next slide, please. Yeah. So when you come to 2019 and 21, the last two slides, RLC is almost sunk. So a water body of something like this in Central Asia, which used to be the main driver of the water security in the region, has shrunk. Now this is something many countries were involved into it. The upper part is Kazakhstan, lower part is Kyrgyzstan. So it's a huge water body, water mass shrunk over time, and this reflects the challenge of water security in days to come. My next slide is going to tell you all what Professor Taikan-san said. When you run the climate scenarios for such a context of transboundary water security related issues, and you run the latest shared socioeconomic pathways, and what is at another important point is to say is in the Central Asia, the observed increase in hot extremes and high confidence, and with this change, the changing climate, which indicates 0.86 to the extent of 3.41. So with this kind of scenario, the RLC-like situation, which is a driving force of the water security, is truly challenging and a matter of a lot of concern. So my next slide is going to tell you what could be pathways for such a challenging security, where such a challenging scenario of water security with transboundary implications. The pathways one requires adaptation metrics, which could be risk informed of the transboundary context of risk vulnerability. So that includes improving dryland agricultural crop production, which also covers three important sustainable development goals where the region is regressing. Making new infrastructure resilient. You see, this is another corresponds to three important SDGs. But what is the one which I would like to bring to your attention is making water resources management more resilient. And this has been the key issues in the RLC shrinking. Water resource management more resilient. That holds the key for many of the challenges in a transboundary case like RLC. Nature-based solutions, of course, multi-hazard early warning and risk assessment. So putting all this together in a transboundary context is something where solution lies. My next slide is going to share with you the pathways to. As I mentioned to you, resilient water infrastructure holds the key. But then the approach of resilient water infrastructure needs to be water energy hood nexus approach. I have just 4 points in this regard. One, this is taken from Infrastructure for Climate Action report that was released in 2021 at COP26. Infrastructure responsible for 79% of the emission, but 88% of the adaptation cost. So that's the key, and it across the multiple sectors. The second point is water sector is the critical, and that's the main purpose of today's our discussion. It adapts the impact of climate change and 54% of the adaptation costs. So making water infrastructure resilience has many opportunities to address the future challenges. Now, third point is integrated water resource management, particularly the interdependence of water infrastructure sector, and it impacts across the subsectors, particularly natural resources and environment, the society. The new generation water infrastructure must be gray and green to reduce the flood risk management and protect coastal cities. My next slide is on Pathways 3. Pathway 3, I would like to bring to your attention a different context. This is the context of Assam, India. This is one of the largest flood risk hotspots. This is a place where poverty, environmental degradation, and disaster and hazards all intersect. Now, this is a case of Assam floods, just ongoing floods. It started in May, it's still continuing. This is captured by, I'm happy my colleague from JAXA is here. This is captured from Sentinel Asia images. The Sentinel Asia captures the 3 flood-prone districts, which I'm referring to you on the right-hand side. But at V-Service, we have the advantage of SDG localization of those districts which were affected by flood in Assam. You will surprise to see the SDG 2, which is hunger, is in red zone everywhere. SDG 13 at another red zone. So climate action, hunger means food security, which is linked with water security in Assam case. So if you design your interventions, particularly the social interventions, environmental integration, social integration on food security, nutrition, hunger, and then you look at disaster risk reduction. This is the approach which is Pathways 3. So this is where you capitalize on technology to capture flood in real times and design intervention to reach the most vulnerable. My last slide is just to thank you for this opportunity, and this is a risk and resilience portal. Most of the slides that I presented are based on the data, especially the shared socioeconomic pathways, related data, socioeconomy available here. So thank you once again for this excellent opportunity. Thank you.
Mark, you're on mute.
Thank you very much, Sanjay. I'm sorry, I was on mute. Can I just acknowledge that we've got some questions coming through, and we'll get this perhaps just ahead of the panel discussion. Can I ask Dr. Masaki Kachi to present, please? He is a senior researcher at the Earth Observation Research Center at the Japan Aerospace Exploration Agency. I think you'll find this presentation very interesting. Thank you, Dr. Kachi.
Thank you, Mark. Thank you for giving me the opportunity to have introducing the issues from this space point of view. I'm Misako Kachi from JAXA Earth Observation Research Center. I'm mainly working for the Earth observation at its long time. Okay, so as you know, the Pacific region is vulnerable to the water-related disasters. So therefore, we have the striving to improve the weather forecast accuracy with the ground instrument and the space-based technologies. However, and there is not enough. And this table shows the population of the ratio and the of the deaths due to the water-related disasters, and the 8 of the top 10 country in the Asia Pacific region, and including Japan. And we need to further improve the phase of forecasted and other preparation for the evacuation action well in advance. Furthermore, it is essential to improve the projection accuracy of the climate crisis, which is a major factor of the water-related disasters, and to prepare for the future with long-term perspective. So satellite data has several advantages in Earth observation. So wide coverage, global consistent, and the borderless capability. In addition, its observation opportunities are not affected by disasters on the ground. So we believe the space technology helps addressing these challenges in collaborating with meteorological agencies, hydrological agencies, and also the policymakers. And so in addition to real-time monitoring of the Earth status, it's important to accumulate the observation data in the entire global consistency over the long term. Currently, JAXA is operating the 6 Earth observation satellites with 4 under development, especially as for the global water-related observation. We continue to observe the Earth by using the precipitation radars and microwave radiometer and synthetic aperture radars on board the series of satellites. And we conducting global observation for more than 30 years. And I would like to introduce the use case of the Earth observation data from this slide. The Earth observation satellites are capable of monitoring the entire situation of the water-related disasters. So this is in July 2020, the Kyushu region in Japan suffered tremendous damage due to the strong and rainy season front. The Kuma River in Kumamoto Prefecture had overflowed, causing widespread flood around the river. The AROS-2, the JAXA satellite, observed the flooded areas changing from day to day. That is denoted in the blue color. So it has advantage of the observing Earth regardless of weather or sunlight, on the condition, and can acquire data when observation by aircraft and drone is difficult. So this data is in response to the request from the national and local government. This data is provided to them. And for the minimization of the damage, disaster prevention and mitigation before the disaster is also important. The JAXA has developed the global rainfall map, satellite map of precipitation product. So it's a satellite-based 0.1 degree grid and hourly global rainfall dataset to monitor global rainfall map in near real time by combining the multiple satellite data. And the rainfall monitoring GISMAP is in wider area, including the over ocean, has been used in the meteorological agencies in Asia Pacific region, where ground-based observations are not enough. It's contributed to the WMO's initiative of the space-based weather and climate extreme monitoring, and also for the agro, and it's also utilized in the agricultural field and the collaboration with Ministry of Agriculture, Forestry and Fishery in Japan, and it's leveraged for the agrometeorological information to project the impact of the agriculture and the production or by the drought or flood. And furthermore, the rice growth outlook for ASEAN country is provided monthly to contribute for the food security. So, and the next slide, we'll introduce the use case of the GISMAP for the flood control. So in the partnership of the JAXA, ICHARM, ADB, and UNESCO, the integrated flood analysis system, IFOS, has been developed by combining a GISMAP in-situ observation and the topographic data for the purpose of issuing flood alert and leading life-saving evacuation actions. So this the effort is introduced to the river basins in Pakistan, Philippines, and so on. So IFOS underpins evacuation activities in this region. And also the mitigate risks and impact with the water-related disasters. It's important to collaborate with model development institute in addition to the advanced space technology. JAXA has developed together the satellite merged global terrestrial hydrological simulation system under the joint research with the University of Tokyo to enable to simulate the global water cycle system in the past, current, and future. JAXA's satellite technology is integrated with the ground surface and river routing model developed by the University of Tokyo to produce the various hydrological parameters with risk indices. The system is currently produced the product in 0.5 degree grid for land and 0.25 degree grid for the river in global area, and 1 kilometer grid in Japan, But we are planning to upgrade the system and to 10 kilometer spatial resolution in global area in near future toward in a future super high resolution model of 1 kilometer spatial resolution. The last slide is, and we currently preparing for the future Earth observation mission. So JAXA continuously and evaluationally promote the satellite observation in order to contribute to the area of water, climate change, and the disaster. From this year to next year, and we are planning to launch the LS3 optical sensor and the LS4 radar sensor for the disaster map and the land mapping. And EarthScale is a JAXA joint mission for the cloud, the aerosol, and the radiation budget. And the GOSAC GW, it's observing the water cycle variation and also the greenhouse gases. And in future, and we are starting the project for the precipitation measuring mission, PMM, for the observation for the precipitation and the convection. So that's all my talk, and I hope that the satellite data will be contribute to the addressing the water issues and challenges in the Asia Pacific region. Thank you for your attention.
Thank you, Dr. Kachi. That was very interesting. I want to move quickly to our next presentation. We're moving to the cryosphere. Dr. Mandira Shrestha from the Program Coordinator for Climate Science at ECMOD. Thanks, Mandira. I can't hear you. You've got your mic. Thanks.
Can you see my screen?
Yes.
Full screen?
No, not at the moment. It's just...
Now?
Yes, that's in presenter mode now. Thank you.
Great. Thank you very much, Mark. A very good morning to all of you. I'm delighted to be part of this program here today. And I thought I'd speak about climate services for building resilience in the Hindu Kush Himalayan region, very much linking to what we are talking about in terms of water security and importance of data and information. Now, to those that you are not familiar with ACMOD, we are an intergovernmental regional organization. We're located in Kathmandu, Nepal, and we are primarily working in 8 countries from Afghanistan, Bangladesh, Bhutan, China, India, Myanmar, Nepal, and Pakistan. And primarily, we're looking at sustainable development of the Hindu Kush Himalayan region. And when you talk about the Hindu Kush Himalayan region, we're talking about a region that extends about 3,400 kilometers from east to west. There are about 240 million people living in this region, but also feeds more than 1.6 billion people living in the downstream. And as you all may be aware, we are the youngest geological formation, therefore this makes us very dynamic as well as a fragile environment. And we have high spatial variability in terms of not only topography, but also climate. And given the fact that we have the largest reserve of snow and ice outside the polar region, we are also known as the third pole. So that introduces to you the Hindu Kush Himalayan region. And now in that context, some of the key issues that are similar to other mountain regions in the region is that in the Hindu Kush Himalayan region, there's cascading multi-hazard environment. We live in a multi-hazard environment. Whatever happening upstream is very much impacting those living in the downstream. So water security is a key issue in terms of depleting glaciers and downstream impacts. So climate change and variability is having profound impacts in the environment of the region. And given its remoteness, given its steep topography, connectivity in terms of access is also quite a challenge. And governance in terms of institutional mechanisms are also rather weak. Given that, I'd like to draw your attention to the climate context. Now, ISIMO, along with its partners, had conducted a study that was showing that the Hindu Kush Himalayan region is really warming much faster than anywhere around in the world. So if you're talking about a 1.5 degree world, then in the region, the Hindu Kush Himalayan region, we're seeing that the temperature is about at least 0.3 degrees higher. And then in some areas, it's even higher, like in Pakistan area, in the Northwest Himalayan, and the Karakoram region. So this was a study that was done in 2019 as the HIMAP assessment. And this very much agrees with the findings of the AR6 report that was launched just last year. Now, given that fact, the region is extremely prone to disasters. So when you're looking at the data sets from EMDAT, we see that when you look at events, people killed, as well as economic loss, the floods alone account for 55% of the events. And when you're looking at it in terms of the people killed, fortunately, the number of people being killed by floods are reducing. But again, the economic impacts are extremely large, and that we find that more than 1 billion people are at risk of these increasing intensity and frequency of these disasters, really challenging our water security in the region. So when you're looking at it in terms of people affected, we're looking at about at least, about 63% of all those people that are affected are floods alone. I thought I'd put this slide because this compares to the slide that was presented by WMO, the World Meteorological Organization, for the globe, which shows that the floods around the globe is much less than 63% in terms of people affected. It's about 46%. So this really shows that the region is extremely affected by these flood disasters in the region, really needing concerted efforts to reduce the impacts. So I'll give you some examples of the recent events. In the Chamoli disaster that occurred in India, infrastructure is key in terms of the disasters that are happening, not only in terms of people killed as well as the livelihoods, but infrastructure. So these are huge infrastructures, the hydropower projects that were near completion that completely got washed away. There were more than 150 people who were killed, and this was in India. In 2021. Similarly, in June of 21, again in Nepal, there was a huge flood, cascading disasters. So it's not only one event you're talking about, you have multiple events. So you really need to look at it in terms of a new way of looking at cascading disasters and seeing how we best really address this to reduce the impacts. So some of the key issues that we've learned from disasters, yes, climate networks are very limited, and it's very challenging in terms of data assimilation into the models that have been presented earlier. We need in situ data, but again, it's very limited. And so, and whatever data is being shared is also quite sensitive often, and then shared very little. And then the institutional mechanisms that are in place also need to be strengthened. And then communication is a key. So when you talk about disasters, risk communication, dissemination is also very important. And then understanding of these hazards. And often risk assessments is minimum. So this is very more climate risk assessments for informing a better, robust infrastructure development, putting in more climate risk parameters in place. So when you're looking at these, in terms of reducing the risks and vulnerabilities and exposure, we're looking at three elements: the hazards, the vulnerability, and exposure. And then therefore, all these three needs to be reduced. And therefore, we're looking at, gender mainstreaming, because disasters, often women are the ones that are affected the most, and governance needs to be improved. Partnerships are critical. We need to improve our knowledge base, financing in terms of investments, and then ecosystem resilience. We talk about green growth, and I think this is very important to look at nature-based solutions. And then science and technology is also critical in terms of addressing these, in terms of putting early warning systems. So data and information is critical. We have a definition from the World Meteorological Organization in terms of looking at science-based information, really to empower decision makers to manage the risks and take opportunities of these And so we're talking about production, delivery, and use by policymakers, by operational agencies, and then looking at different scales. We're looking at it from the continental, the global scales to the regional and national scales, and those that are being benefited at the local level. And then we're looking at different time scales, historic data information. We're looking at the weather forecast, the 3-day forecast, then the seasonal, and then annual, and as the projections, which is important to look at future in terms of what is happening in the future. So there are various risk-sensitive growth sectors, of course, we're all aware of that: agriculture, tourism, water and energy, which is critical, health, and then disaster risk reduction. So there needs to be proper climate services put in place so that we address the needs of all these sectors in terms of minimizing the impacts and taking the maximum in terms of the opportunities. So then the opportunities, yes. So harmonization of climate and data and information is again an opportunity in terms of standardization, looking at methodology assessments, looking at these to improve climate resilience. Capacity building, I think this has not been talked about yet. Capacity building is central in terms of improving the adaptive capacity to climate change. We have talked about science and technology. Yes, all these tools that were presented, like Ms. Sato-san, she presented about the Earth observations. Yeah, they play a critical role in terms of monitoring as well as assessing and forecasting. Very important in terms of having in place a gender responsive, I call it a gender responsive climate services, because it needs to address the needs of the women and the marginalized communities as well, because often it is not reflected. So therefore, there needs to be concerted efforts to look into what are the different needs, differential needs of women in terms of addressing these challenges that we heard. And another opportunity is that we need to really co-create some of these innovations at the local scale in terms of better interpreting some of these, understanding some of these for informed decision-making. The slide here you see of these ladies sitting around. This is a work that we are doing in Pakistan on climate services in terms of assessing the socioeconomic benefits of climate services and better understanding the needs of women in terms of getting these services and making best use of it for the agricultural productivity and water security. And also important is to enhancing partnerships and regional cooperation. So with that, I just want to end with this slide here, talking about the ICIMOD 2030 strategy. So embarking from 2023 onwards, ICIMOD is going with a new strategy. And here we're looking at a more greener, more inclusive and climate resilient Hindu-Kush-Himalayan region. So I would like to end my presentation now. Thank you very much. Over to you, Mark.
Thanks, Mandira. Can I just, there's one question that's come up that I'll ask you now. Where Kent was referring to the slide on the increase of temperatures in the region. Did the team also consider spatially mapping forest cover or deforestation against the heat map? So he's interested to know if there's a relationship between deforestation and temperature.
Yeah, in that particular study that I showed you, that did not, cover the heat map or the forest cover. That was exclusively looking at climate change projections using Cordex data sets of South Asia.
Thank you. Thanks for that. Can we just move to the panel now? Perry Rivera is joining the panel, but Perry may not be here just yet. He was called away to a meeting. But I'd like our speakers plus Sasawati Beliapa, who's a senior safeguard specialist at ADB, to join the panel.
Thank you, Mark. I thought I'd just talk a little bit about ADB's work and our projects and operations and how we tie up all these aspects together in our operations. And first of all, I'd just like to inform everybody, just in case you're not aware, that ADB has announced a goal of providing $100 billion in climate finance from its own resources between 2019 and 2030. And ADB is also aligning its operations with the goals of the Paris Agreement, and the alignment process is expected to be completed by July 2025. Let me just share a couple of examples of a few projects that I have been involved in. One is the West Bengal Drinking Water Sector Improvement Project, which will provide safe and sustainable drinking water in arsenic, fluoride, and salinity affected areas of 3 districts of West Bengal in India: Bankura, North 24 Parganas, and Purba Mednipur districts. So it will introduce innovative and sustainable institutional frameworks, advanced technology for smart water management to enable efficient service delivery in rural areas. So let me take the example of Purba Mednipur district, which experiences recurrent cyclones and salinity intrusions with rise in sea levels and underground sweetwater spots being destroyed by tidal and cyclonic flooding. So the project undertook a detailed study of salinity measurements from 2010 to 2019, and pilot modeling was undertaken. Based on this, mitigation solutions were identified, potential solutions were identified, and then the most practical ones are being taken up under the project. And apart from the use of technology for these studies on salinity modeling, there is a huge component of rural livelihood resilience improvement. There is a Japan Fund for Poverty Reduction grant that supports livelihood resilience and social inclusion and gender equality in the project. It is rated as a gender equity project, which is the highest rating for gender mainstreaming in ADB, and ensures that the poorest and most vulnerable are identified and included in project benefits. So this is an example of a project that marries technology and social aspects and hydrology very well, just as Dr. Taikan Aki was mentioning. And in addition to all of this, water and sanitation safety plans have been prepared by pilot Gram Panchayats. And these use technology through smart water management to capture the output results for defined parameters for monitoring. So that's about the West Bengal project. And likewise in Kathmandu, we are currently designing the second Kathmandu Valley water supply improvement project. And we are, just as Dr. Mandira Shrestha mentioned in her slides one of her slides on Melamchi flooding, we are taking that into account, and a disaster risk assessment studies underway, which will inform the design of the project, the location of the intake, and the selection of the intake, etc. And likewise, in the second Coastal Towns Environmental Infrastructure Improvement Project in Bangladesh, again, highly disaster risk prone area, we are looking at not only resilience of municipal infrastructure being improved, but also livelihood resilience improvement and institutional capacity and governance improvement. So with that, I'd like to stop here. But I would also like to mention that ADB is launching an open platform, the Water Resilience Hub. I think it will be, the web page will be launched on Thursday this week. And it is an open platform dedicated to strengthening water security in the region by forging partnerships and providing training opportunities, sharing knowledge products, etc. And it will bring together experts, policymakers and managers and water implementers. We are really looking at how to build the resilience of water entities on the ground through the hub. So thank you very much.
Thanks, Asawari. It's yes, we look forward to the launch of the Resilience Hub. I think Perry's still not with us, but can I go to the panel, please, and thank you for your presentations. There are a few questions coming through, and perhaps to Dr. Oki, the ADAPT project is truly amazing, says Tran. Is there intentions of expanding the project to other countries? I know that in Vietnam we're experiencing all of these risks addressed in the project, and the project would be extremely helpful in guiding decision makers to mitigate and adapt to climate change.
Yeah, thank you very much for the question. That the project was expected to have the more dissemination of its accomplishment to the neighboring nation, including Vietnam. However, at this moment, we do not have the concrete program or project to support our activity to expand that our experience and the result we got from the adaptee. But we need to think about more engagement with the neighboring nations to certain activities. Thank you very much.
Thanks. Another question from Wesley. Due to climate, this is probably for you as well. Due to climate change, the hydrological data that was considered for the analysis needs to be revised every year. What are the recommendations to fix the hydrological parameters for climate resilience design to face future challenges?
Is a question for me, Mark?
Yeah, I think so, yes.
Okay.
Yeah. Well, I'll direct it to you anyway, and anyone else can try and answer.
Thank you, yeah. So, okay, maybe Shibatari-san knows better than me, but in Japan, that the national master plan of that the river basin management for floods were now under review to increase that the design flood level. And so I think that every nation can consider to review what could be that the possible design flood at the end of this century. But not only considering that climate change, we have to think about the development, social development, either that population growth or the expansion of the cities, but at the same time, some nations, including Japan, we have the projection of their population decrease. Therefore, that we have to think how to shrink that the protecting area, so that this kind of the future projection for the both that climatics or the hydrologics situation and also social situation should be considered.
Thank you. Mandira, I've got another one, or a thank you as well. Thank you for underlining the role of gender mainstreaming in your presentation. This is from Kent. Would you also share some insights about how we can integrate or strengthen evidence about women's roles and women's leaders' value when analysing data on climate change studies to solidify scientific support towards gender mainstreaming versus anecdotal evidence?
Yeah, thank you, Kent, for your question. because gender mainstreaming has been a challenge in terms of really integrating it into our programs and projects. Often this is something that is coming really at the end, at the very end. We say, oh, gender, we forgot about it. Let's just now integrate it. Yeah. So it is important that we look into mainstreaming gender right from the inception, right from the beginning. So we look into the needs of the women and the marginalized communities and integrate that into the projects and programs in order to have a more resilient kind of a program in place. So that is what I have to say. And in response to an earlier question regarding more this climate resilient design and how it should inform, hydrological processes or designs. I just wanted to give you an example of what we also have been addressing. We recently had a workshop with hydropower stakeholders in Nepal, and one of the biggest challenges they're facing is the increasing climate risks. So it is really extremely important to understand the climate extremes in terms of what it is going to be in the future. So in looking at both, in terms of the historic data, but also looking at the future climate and coming up with a more of a robust climate risk assessment, which would inform these designs in the future. In the past, we've been mostly looking at historic data. We're looking at climate data for the last 30 years and then, or 40 years, whatever is available, and then designing. But now in the changed context of extremes, we need to look at that. Also, of course, I do agree with Heiken that we need to look at the social changes as well in terms of integrating that into the design. Thank you.
Thank you. Sorry, I'm checking on questions. Muzaffar asks a question in terms of minimizing the occurrence of floods. What is most important to address, either climate change or building storage reservoirs? It's an interesting question. How many storage reservoirs do we need to hold those massive floods?
Who is that question for?
From Muzaffar.
Oh, for whom? Is it for me? Or
yeah, I think, yeah. Yes, you can try and answer that.
Yeah, I just mentioned hydropower, I guess, or infrastructures. I mean, yes, it's not about only putting in, huge storage dams. I think there was a study that was done several years ago regarding the storage versus, the floods that are occurring in the region, the Hindu-Kush-Himalayan region, particularly the Ganges and the Brahmaputra, and as well as the Indus. So it should be, not looking at just the infrastructure as such, but more of a mixed approach of how it can be better tackled. Yeah.
Certainly here in Australia, some of the floods we're getting, and there's public debate about increasing the height of dams, but some of that's quite impractical from an engineering point of view. So there's some interesting community debate about that.
Yeah, and there's more increasing debate about when we talk about nature-based solutions. We are probably looking at also more watershed management practices and the way people are handling. So,
yes, holding water in the landscape.
Yeah, so that becomes also critical.
Yes. I'm wondering if panel members have questions of each other. Yes, I can see you wanting to ask something. Sanjay, are you?
Thank you, Mark. I think it was truly a panel which complements each other's opinion. While I flagged off the pathways, 3 pathways. One is a transboundary water security context of Central Asia, RLC. Then the water resilient infrastructure, its interconnectedness. Just now the question was on this storage versus climate risk. So the interconnectedness is very important point to look into it, especially the upper reaches, downstreams. And the third one is the pathways 3, which is in the most vulnerable context. Again, it's interconnectedness, whether it is hunger, poverty, gender, all these issues together. So I think many of the pathways that I highlighted in the presentation, 3 pathways, my colleagues, it's a great to hear from them, particularly Professor Uki, Madhira, and the colleagues. They exemplified how technology can play a role, climate services can play a role. So I think I could see a good storyline coming out of this panel discussion, coming out of this session. So thank you, Mark.
Yeah, Mark, can I just
Yes.
want to with yeah, thank you. Just adding on to what Sanjay has just said, I think critical for our region is transboundary cooperation and collaboration. I gave an example of floods, but whether it's floods or droughts or storms, I think critical is the transboundary collaboration. So there does need to be that effort put in place to really one is to, of course, share knowledge and experience. I think that came out also quite clearly in terms of that opportunity. But also critical is also the know-how, the information that exists need to be also shared across borders, because when you're talking about all these different types of events that are affecting our water security in the region, it really knows no border is what I call it. So therefore there needs to be that effort that needs to be put in place. And I think the forum should also have this message clear that there needs to be more collaboration and cooperation across borders in order to address these increased challenges that we are facing. And I think Earth observations do play a very key role in Misako in his presentation, and then she gave examples of IFAS and several of those products that are there in order to address some of these issues. And I think capacity building it needs to be continued for the use of these products and these science-based information that are now coming. And these capacity building efforts need to really empower the users in terms of making use of these tools and technologies, and also leading it down to the users. I think we have not yet spoken too much about the end users, where they are the actual beneficiaries in terms of making use of whether the results of a climate data model or tool or early warnings that reach them. So it is important that we also need to look and see how we increase our outreach down to the users and make sure that they are also at the same time empowered, as well as the awareness and the capacity built at that local level. Of course, all institutions, every institution cannot do that. But again, the partnerships is critical in order to reach out to them. So what kind of partnerships we need to put in place so that we are able to make that last mile in terms of saving lives, property, and improving other livelihoods. Yeah. Thank you.
That's really good. That notion of, a notion of inclusiveness, I think certainly does include, building capacity, particularly in the community. I might come to you in a moment, Misako, but Sasawati, you've got your hand up.
Yes. Thank you, Mark. So just reacting to what Mandira said a little while ago, I'd like to react to that. So giving an example from our West Bengal project, which I was talking about a little while ago. Here we have these Gram Panchayat level management centers being set up, and those are completely managed by the community. And there are smart water systems in place, which will be used by the community, and women will be employed in large numbers in those centers. And basically, the project has involved NGOs and local partners, including the administration, to better mainstream gender on the project, and mobilized women to prepare early for resilience and any kind of events that take place later. So this is an example that I just wanted to share.
Thank you. Masako, did you have some reactions to Mandira's comments? I think for me a question about the satellite data is very much accessibility, and but please, yeah.
Thank you, Adi. Thank you for question for Sanjay and the Mandira's for the follow-up for the and mentioning the satellite data. And I think that, as Mandira already said, that this satellite data is quite useful too if you can use it properly. And it's can observe the area in the global and also in the region, and both data is available. And most of the satellite environmental data is free of charge, and maybe everyone they can access to the data. But still, there is some difficulty in the data handling, and I think that we realize the needs of the capacity building, how to handle the data, and also how to apply the data into some kind of a tool or the application. What is the policymakers and in the government officials using? So I think that we think that it's a careful dialogue with the stakeholders is quite needed. And I expect the EAVs the contributing such kind of areas, and the JAXA is quite the positive to collaborate with this capacity building through the EAVs activities. Thank you very much.
Thank you. I've got a question or a comment and question from Clive Lyle. There were some powerful examples of disasters given. Does the panel think that it is truly feasible to address these major disasters with technical solutions, or whether social adjustment needs more consideration? It's a good question. Sanjay, you look like you want to answer that.
Thank you very much I really like this question, because we have to think something out of box solutions, and transformative adaptation. I think one of the pathways that I highlighted, the 5 key. So the adaptation needs to be transformative, because as of now, many of the solutions that exist, it doesn't have that kind of what my colleagues were suggesting. They did not visualize the climate extreme, but if you recall what we are experiencing today, in the beginning of the pandemic, there was all kind of, the whole world was rattled. But today the world is satisfied, to more confident, because we have vaccinations, we have many understanding about the risk. The same is in the climate extreme or the future climate scenarios. We have technology, we have innovations, we have science, and they are all advancing at a very, very high pace. So it's a time to capitalize on those, and that is where adaptation transformative adaptation to extreme climate events, the solution lies there. Science, technology, innovations. So thank you.
Thanks. Any other response to Clive's question? Yes, Mandira.
May I, Mark? Yeah. Well, yes, it's important that we have the technical, looking into the technical aspects as well as the social aspects. But I'll just give you an example of what we have been working on in terms of looking at both the technical aspects and just excuse me, just a minute. Yeah, there's just a minute. Hold on.
Crowd control, Mandira.
Okay, so sorry for that interruption. What I wanted to bring out is, yes, it's important that we look at the technical aspects, but when you're looking at the entire system, I think we need to look at it in a system, approach, because we're looking at an end-to-end system, where the data is being generated, where the data is being processed, where information and early warnings or any kind of information is being generated and then processed and then also communicated and then actions on the ground. So this whole process that I mentioned, this whole system, it has three parts. One is that you're looking at the technical part, in which we are getting better every day and day. And the technical solutions are there. But also there is this governance aspects, that's the institutional aspects. A bulk of what we are trying to do is also really not being addressed or weakened because of the weak governance systems, the weak institutional mechanisms that we have in place. So that also needs to be strengthened. And then of course, definitely, like was said, the social aspects, the social cultural, I bring in the cultural aspects too into it. So all three components need to be there and balanced. So you have the technical aspects, the institutional aspects, and the social cultural aspects that need to be taken into consideration. And so it's like a chain. So each of these need to be really strengthened in order to make sure that the people's lives and livelihoods are saved. Infrastructures are more resilient. So I wanted to bring that additional dimension of institutions that needs to be also looked into, the governance aspect for minimizing these risks. Yeah, thank you.
Thanks very much for that, Mandira. I'm afraid I've just about run out of time. There are a few questions left. Can I ask the speakers to go into the system and have a look at the questions that are there and address them later. I'd like to introduce Mikio, or Dr. Mikio Ishiwatari from the Japan Water Forum for his reactions or observations on the session. Thanks, Mikio.
Yeah, thank you very much. Yeah, thank you very much for very useful and informative presentation and discussions. Well, I don't have so much to add, but from a Japan Water Forum perspective, I would comment a few. Yeah, well, today I could understand science and technology is essential and crucial for promoting quality growth. It's resilient, sustainable, and inclusive growth that the president and the prime ministers agreed in Kumamoto. Yeah, because of science and technology, we can see future, not perfectly, but somehow we can see. And we can know some risks. Such information definitely needed to secure financing investment in water sector. Policymakers and politicians, decision makers, definitely they need this. And the secondary already discussed governance. To establish governance, these information are needed for stakeholders, civil societies, river basin organizations, human groups, etc., etc. So this financing and governance is a key accelerator that identified in Kumamoto Declaration. Yeah, what's the challenge? I understand that the biggest challenge from today's discussion is anyone can become to use these knowledge or tools, satellite or mapping, or you already pointed out some data handling issues. So how we can make anyone can use these knowledge and tools? We expect ADB's water resilient hub just announced. And I understand JAXA is already started talking with them, ADB. And we expect JAXA would be leading some important source for the hub. definitely they can, I believe, and I would expect and I would appreciate Professor Oki's advice or such a suggestion for these our activities. And definitely Japan Water Forum and the Asia Pacific Water Forum would support these hubs activities. Yeah, thank you very much for today's discussion. And thank you very much. We could learn a lot. Thank you.
Thanks, Mikio. I'm going to draw the session to a close. I've got about 60 seconds left. Can I thank all of the speakers and apologize that we haven't answered all of the questions, but the speakers will get to them. Thank you. I learned a lot in this session, and I think, as Mikio said, I can see that the science and technology plays a key role, but indeed governance and finance do as well. In fact, one of the questions we haven't answered was a finance one. But can I thank everyone for their participation, and can I thank Asia Water Forum and NITA's leadership in putting this event together. It was nice to be able to be one of the first sessions. So can I close the session now? Thank you all, and look forward to seeing you at other sessions during the next few days. Thank you.
Mark, can we have